Go.
Hi guys, a very warm welcome to Space Roundup with Nick Howes and Terry Moseley. I hope you guys are all doing well. Thank you for joining us. Thank you for joining us on Zoom. And if you're watching us on YouTube, here's where we bring you the latest and greatest of space news. How are you guys doing, Nick and Terry?
Good, Latch. How are you?
Hi, Lax.
I'm doing very well, thanks.
Right,
I'll let
good.
you guys take it away. I hope everyone joining in tonight enjoys it. And I will meet you back near the end for some Q&A.
Cool. So tonight we're going to do a little bit of a global tour of the solar system and beyond, Terry and I. So we've picked a few, we hope, good stories for everyone. The first one being this wondrous comet that's just kind of popped out of nowhere. So we're all expecting a few comets this year to be good naked eye visibility objects. And then this one comes kind of springing up and surprising everyone. Comet Neowise, named after the orbiting satellite, the near-Earth orbiting satellite, which has been designed for detecting these kind of objects and many more Earth-crossing asteroids and comets. But it's a really good one, isn't it, Terry?
Yeah, it's a nice one. We've been unlucky in the northern hemisphere, at least in high northern latitudes, for quite a while. They had some excellent comets visible only fairly well anyway if you're south of the equator, but this one has already been seen from southerly latitudes, but it's in a very highly inclined orbit and it's moving north quite rapidly. It has already been spotted and photographed from UK, roughly latitudes of London or so, but it will gradually get better. You could even see it early tomorrow morning. Now, at the moment, it is only visible in the early mornings before sunrise, but over the next couple of weeks, it'll become visible in the evening skies, still fairly low down in the north. But tonight, for example, if it's clear, if you go out about 3:30 in the morning, roughly, you should spot Venus, an exceptionally bright object, the brightest star-like object in the sky. It'll be low down in the northeast. And if you look above and to the left of that, one of the brightest stars in the sky, although nowhere near as bright as Venus, is Capella. And tonight, if you drop down vertically below Capella, about halfway down to the horizon, that's where the comet will be. Now, you'll probably see photographs of it, maybe in the news, certainly on the media, on the internet and so on. Those photographs are very impressive, but you will not see it as bright as that yourself, because cameras are very much more effective at picking up faint light than the human eye is. But nevertheless, it is visible to the naked eye, and if you have a pair of binoculars, you get a much better view. Now, it's quite complicated to explain just where this comet will be over the next couple of weeks, but the internet provides any number of sources. You just have to Google Comet Neowise, and you'll find sites that will tell you how to find it and pick something that's suitable for your particular latitude. It's the best comet we're going to see here for, well, probably over a decade. So let's hope it doesn't suddenly fade out as the way some of the others have done.
It's a good point as well. If you wanted to see the comet, I mean, as Terry's saying, looking kind of towards the north, you're going to have to get up very early in the morning at the moment.
Yeah.
But over the coming weeks, it's going to get better and better, and you'll be able to see it earlier and earlier, as in like closer to midnight. So still not ideal for the younger. Go on, Terry. Sorry.
I was going to say, if you know the sky at all, at the moment it is in between the constellations of Auriga and Gemini, and then it will move into a relatively uninteresting part of the sky, and towards the end of the month it'll be directly below the Plough, which a lot of people will be able to recognize.
That'd be nice and easy to find.
Yeah. Now, the thing is that although it's slowly getting higher up in the sky for us, it's also getting slightly fainter because it's moving away from the sun and moving away. Well, it's moving slightly closer to Earth at the moment, and then we'll start to move further away. So we're fighting a sort of a battle between it getting high enough up to get a good view of it and the comet remaining bright enough to be easily seen. So take every chance you get over the next couple of weeks. If you get a clear night, it is worth having a look for this one. It might be the best comet many people have seen.
If you're struggling to find it, I mean, there's mobile phone apps galore for both iOS and Android, that you can basically download the latest sky maps. You can download the latest information on comets. It's pretty easy to do, and then you can literally use your phone as a kind of way to guide yourself around the sky, which is a nice way to kind of pick up and actually learn a lot more of the constellations in the sky as well. As Terry was saying, it has approached the sun. It's reached perihelion a few days ago. So what's interesting, some of the images we're seeing now from some of the more advanced observers possibly are showing that the comet is fragmenting. There could be bits coming off it. There was an image taken by British astronomer Jamie Cooper, which seemed to indicate there was something happening tail end of the comet. It'd be interesting to see some of the high resolution images coming from some of the bigger telescopes around the world, if it is fragmenting. But it's approached, it's got to its closest point to the sun. So hopefully it's not going to completely disintegrate, which is what happened with Comet Atlas. As it was approaching the sun, it broke up. And in the next couple of weeks, we could be really treated to a nice naked eye comet, which would be great.
We're long overdue a good comet, and this, as I say, is probably the best one for people in our latitudes. I'm personally thinking of probably 15 years since we saw one as good as this.
Oh yeah, I mean Terry Lovejoy, one of the Comet Lovejoys was really quite a nice one. I remember that. Obviously Hale Bopp, anyone over about the age of 30 will remember Hale Bopp, which was spectacular.
And Hakataki. Anyway, as I say, take every opportunity to see this one if you want to see a comet. Don't expect it to be just as spectacular as it is in the photos. The other thing, unfortunately, this time of year is that particularly in this part of the sky, the northern part of the sky, it never gets really dark. We have the perpetual summer twilight. So if you're in the northern half of the UK or similar latitudes, you're not going to see it in a totally dark sky. And if you have binoculars, they will definitely help. Try and borrow a pair if you haven't got any. And good luck to everybody.
Be very, very careful though if you're looking at it through a telescope or binoculars, especially as it's approaching kind of dawn in the morning. One slight accidental move towards the sun and it could be really catastrophic for your eyesight. So always be really, really careful with that. So yeah, it is a great comet. Interesting one in that, again, comets, these things they're unpredictable, they spring out of nowhere, and I just want to keep banging the drum for we've just had asteroid day not so long ago. To me it should be comet and asteroid day, because one of these days one of these things is going to be coming our way, and if it is the size of Hale Bopp, we're going to know about it. It's going to be absolutely appalling. So but definitely go and have a look at it. Brings us nicely on to our next really interesting news story, which is this detection of a so-called black neutron star. This is really interesting from an astrophysical point of view. So stars like our sun, for example, towards the end of their lifespan, our star's been burning now for 4.5, 5 billion years, probably got about another 4 billion years or so to go before eventually the battle that it faces between gravitational forces and the nuclear forces that are keeping it kind of burning will be won, and the star itself will start to collapse, and basically it will also expand outwards. Gigantic shell which will increase in size, will swallow up Mercury, swallow up Venus, almost come to swallow up the Earth, and then it will kind of dissipate in this great big poof in the sky, which will look absolutely beautiful. If you're on another star system nearby, it'll look a really nice planetary nebula. If you've seen images of things like the Dumbbell Nebula, as one great example, is essentially what our star's going to do in about 4 or 5 billion years. We won't be around because within the next billion years it's going to heat it up and grow so much and more energy, putting it bluntly, that our planet really won't be inhabitable within about 1 billion years, but we don't have to worry about that. The interesting thing with this, so stars above a certain mass, they do different things. Some stars will explode if they're above a certain mass, some stars will go into what's called core collapse and will form white dwarfs as the end result, which potentially what's going to happen to ours. Some, if they're above a certain mass, will become neutron stars, which basically extremely dense star material, very high gravitational forces, and then above a certain limit, again above that, will become black holes. Now, what astrophysicists have found is that this delineation between the size of a neutron star, the upper size of a neutron star, and the lower size of a black hole, there's kind of this gap where nothing should really exist, but they found something there. It seems like I think it was a 29 mass solar mass black hole swallowed something recently, about 2.9 mass bizarre neutron star, and essentially the LIGO Observatory, which is a large it's a laser observatory, basically fires a beam between 2 points on the ground and detects things like gravity waves going through it. They detected this. It's absolutely amazing, isn't it, Terry?
Yeah, it's fantastic. It takes several observatories to really make sure that something like this happens. One could just be a glitch in the equipment. If two record it, it's almost certainly genuine, but that doesn't give you exact location in the sky. You need a third one to give you the triangulation and give the exact position, and then you try and find out what the object is, if there's any remnant from it. So it takes the LIGO Observatory, which is two different sites in the United States, and then the Virgo system in Italy, and they all detected it. And yeah, as you say, the interesting thing is that theoretically this shouldn't exist, assuming that all the measurements are correct. And they're getting pretty good at this now, actually. There are now so many gravitational wave detections that you hardly even hear about them in the news, unless they're really unusual, just as this one. So they're getting this down to a pretty fine art, and I'd be fairly sure that they're right. They're saying about 2.6 solar masses for this one. And as you say, that's too big to be a neutron star, and it was thought to be too small to be a black hole. But according to what I'm reading at the moment, the latest thing is that it is actually a lighter than usual black hole. They thought no black holes would be more than 5 solar masses, and this is about half of that. So there's a lot of work still to be done on this. And this gravitational wave astronomy is really opening a whole new window on the universe.
It's it, and it was a collision with a 23 mass black hole. So, as Terry was saying, the LIGO Observatory is just one. There were all sorts of hopes for space-based observatories to do the first gravitational wave detection. I remember I worked briefly on the LISA Pathfinder mission, which is a European Space Agency mission designed to kind of prove the techniques of putting two spacecraft several million kilometers apart, firing a laser between them and having highly polished beryllium cubes, basically free floating. And if you fire the laser between them, basically this laser beam would be deflected by the passage through it of a gravitational wave. What was interesting with this, the amount of deviation, the angular deviation of this laser, if a gravity wave passed through it, this is how sensitive these instruments have to be, is essentially the width of your little finger at about the distance from the Earth to the nearest star system, being Proxima Centauri. It's absolutely astonishing. And if you think on ground-based observatories, you've got to be able to filter out everything from a truck passing maybe 100 miles away to microquakes from, the Earth is obviously constantly under microquakes, which are now being detected on Mars as well. But this is really, really interesting. It's a fascinating discovery. One definitely to keep an eye on, one that's getting all the astrophysicists really exciting. So definitely one that I'm going to keep following. Because, like I said, I've got a vested interest. LISA Pathfinder was the kind of precursor to this big LISA mission, the large kind of in-space interferometer system. Yeah, it's amazing. It's absolutely amazing. So, on that bombshell in astrophysics, we'll move on to something a little bit closer to home. So, we've gone out to the depths of the universe, back to the race to Mars. So, as we now know, the European Space Agency's mission, Rosalind Franklin's been suspended now for 2 years. They had issues with parachute testing. There's all sorts of things that they're still trying to check, and there was issues with software. So thankfully, they've decided, okay, we'll wait until the next optimal time for an Earth-Mars transit happens, which is in about 2 years, every 2 years. But there are several missions all taking off pretty much at the same time. So we've got the United States with their Mars 2020 rover, which is going to take off now around about the 30th, they hope, of July. Just before then, there's two sets of missions. One is an incredibly ambitious Chinese mission called Tianwen-1, or part of it is called Tianwen-1. You can see it on the screen now. So this is a combination. This is the first time China have really tried to do an interplanetary mission out to Mars. As we know, most of the Mars missions actually fail. There's a good high percentage of Mars missions. Nothing Russia's ever launched, for example, has ever successfully landed and performed surface science on the Martian surface for more than a few seconds. So it's incredibly hard. And yet China are going for this radical mission where they're not only having a lander, they're going to have a rover and an orbiter at the same time. I think this is amazing. There's scant details coming out of China on this. Some really nice images, like I said, the one you can see on screen here. It's going to have the ability to do subsurface radar measurements. There's a whole raft of things that they're trying here. If they're successful, it'll jumpstart them. It'll literally leapfrog them into the kind of A-League, as it were, the Premier League of Martian exploration. What are your thoughts on that one, Terry?
Yeah, I think they're being very ambitious, but they have had a pretty good record so far. And there's three three options for success, if you like. If even one of their things operates, I don't see how the rover can operate if the lander doesn't, because it takes the lander to get it down there. But if all three work, it'll be an absolutely amazing success, something that nobody else has managed to do. But to even get the orbiter to work will be pretty good going. And if they get the lander down and the rover works as well, that will be, beating everybody at their own game. And the only other country that has had a successful mission to Mars at the first attempt is India, and that was just an orbiter. But so many, I think it's 10 out of 18 is the success rate for attempts to get a lander on Mars, which is only just over 50%. But who knows, as you know very well, Nick, the Chinese don't give too much away in advance, so we don't know an awful lot of detail about this. But I wouldn't be surprised if they succeeded.
Yeah, it's a long March rocket launch in a few weeks' time. They've literally got to launch in a few weeks' time, as I said, because of this kind of, the proximity of Mars to the Earth and the way that the orbits work. There is literally just quite a narrow window when these kind of launches can occur. It's very, very interesting, as you say. It's as optimistic and ambitious, I think, as the Sky Crane when NASA landed the MSL a few years ago with Sky Crane, and everyone was saying that was completely crazy, but they managed to do it. This is kind of a halfway house between almost like what Viking was doing and Spirit and Opportunity. The rover's nowhere near as big as the NASA and European Space Agency rovers, which are going down. It's more akin to kind of Spirit and Opportunity in terms of size, but very, very ambitious mission. The other one is the United Arab Emirates. Now, this is kind of a bit of a curveball that's come out of nowhere. So the Japanese Space Agency, JAXA, are going to be launching a mission on behalf of the UAE. So obviously Middle Eastern territory, not really renowned for their space agency or their space expertise. But again, they're trying to really do what India did very successfully for only $75 million in the case of the Indian mission. And that's get an orbiter around Mars. The science payload on this is nowhere near as ambitious as the Chinese mission, but it will be, again, a really great notch in the bedpost, as it were, for the UAE Space Agency if they manage to pull it off. Do you know what you think, Terry?
Yep. Just going back briefly to the China one of the interesting things about it is that they are attempting to land in the safest area possible rather than the most scientifically interesting. They've chosen two possible landing areas, both of which are very low down in terms of altitude, and that means you get more of the Martian atmosphere to give you effective braking. So you could say they're playing fairly safe on that. But back to the UAE, they're saying that this is not so much a primarily science-based mission, but is to try and encourage the Arab world to show that they can do this, to encourage their youth to get into science and technology, to give them a sort of a showpiece that they can be proud of and aim for. But certainly it will have scientific instrumentation. They'll be studying the Martian atmosphere in considerable detail. So it's interesting. Japan, I think, already launched a satellite for the UAE some time ago, and they built the rocket for this one quite a while ago. So not so ambitious, but for UAE to attempt this at all with very little history in space exploration, again, it's a very encouraging sign that they're even interested. The more people that are in the game, the more successes it's going to be. And almost without exception, all the science is shared between all the different countries. There's no real sort of political barrier to the Chinese sharing what they find out about Mars to the Americans and vice versa. The technology, maybe, the computer science, maybe, but not the actual scientific findings.
No, that's true, and it's obviously been demonstrated with the U2 mission, obviously, which is on the far side of the moon at the moment, and China have been sharing an awful lot of data from that, giving both the US and the European Space Agency lots of additional insights with the plans that are now very well advanced for the return to the moon by European Space Agency and NASA with either the SLS Artemis missions or potentially with SpaceX at some point. We don't know who's going to get there first, but as Terry said, it's really nice to see the politics kind of fading by the background. If you look at what the UK situation is at the moment with Huawei and 5G, and the UK government saying that they're probably going to eliminate China from any part of the 5G infrastructure over the coming years, it's really nice to see that this level of scientific cooperation is still really, really prevalent. Interesting with the UAE though, obviously they've got JAXA launching it for them at the moment. Predominantly, this is something I've been involved in with some of the work that I'm doing in my day job. There are issues with launching from such a volatile region. The UAE is obviously the Middle East, and Middle East is quite a volatile region. So you've got enormous issues with range safety and launch safety. So at the moment, they're utilizing people like JAXA, etc., to do launches for them. Potentially, though, in the coming years, they could have their own launch facility. That may not be from the ground. Can't say too much more from that. They're maybe all sorts of other options, but it's an interesting one to keep an eye on, because if they are successful here, as Terry was saying, they're really going to pursue this and push forward not only the STEM aspects of it and encouraging the youth of the Arab world to kind of get more involved in science, but I think you're going to see a lot more from these guys over the coming years, so it'd be interesting.
Very good. Just sorry to interrupt. Very good to see that area of the world get involved again, because for many, many years, for many centuries, they were the leaders in astronomical research. Almost all the star names that we use are actually Arabic in origin. And those names came down to us through history when sort of Europe and other parts of the world were in scientific dark ages. It was the astronomers in the Arabian world that were keeping the science going. And we have that tremendous heritage, and we need to be grateful for that.
Oh, absolutely. If anyone's got access to things like BBC iPlayer, or you could have a look on YouTube, there was an excellent series broadcast a few years ago by Jim Al-Khalili, who's a notable British kind of physicist, who talked about this. Really, really fascinating series in terms of what the Arabic nations really did for scientific discovery. And as Terry was saying, you know, whilst we were languishing in the post-Roman Dark Age era, probably from the 4th, 5th century through to the Renaissance, even kind of 15th, 16th century, they were really forging forward in so many different areas of science, along with the Chinese as well, which again is really nice to see China doing so much. We've just passed the anniversary a few days ago of the Chinese observation in 1054 of the Crab Nebula formation and the supernova that caused that, which I thought was quite nice, being celebrated on various social media platforms. But Crab Nebula, if you've not seen it, in the winter nights, winter skies in the constellation of Taurus, it's one of these beautiful kind of tendril-like supernova remnants that's left over, and you can still see the star that was kind of left behind, as it were, the core of the star that was left behind after that, if you've got a decent sized telescope. It's really, really fascinating to see. So on to our last, guys, flown by tonight, our last topic. These guys, Rocket Labs. Now, New Zealand have done remarkable work in terms of getting a launch facility. Peter Beck and the Rocket Labs team down in New Zealand, they basically just went ahead and built a launch facility. It's not as sophisticated, obviously, as what you've got out of Cape Canaveral, but it's a really good model for potentially what we could be seeing in the UK, up in the northern part of Scotland, up in Shetland, Sutherland, Western Isles, etc., over the coming years. And they'd had an incredible run of success. 13 launches, the last 12 of them really, really successful. They had been taking defense launches for the United States government. They've been doing all sorts of classified launches for DARPA, which is part of the US government's kind of secret defense arm. Really fantastic stuff. And then a few days ago, last Friday, they had their first launch failure. It appears that it was an issue with the batteries. It's not been finally confirmed yet, where they got a battery transfer between the different stages. And around about 6.5 minutes into the launch, it failed. The tragedy of this was there was so many great small satellites on it, because this is what Rocket Labs really specialize in launching these kind of small sat payloads, really good scientific payloads. One of which was a British kind of satellite, multi-satellite, as it were, called Faraday, which was designed to host a whole number of different experiments. And also Canon, the camera company, had set up a CCD sensor designed really with a wide field to take some really impressive Earth observation pictures. I really feel bad for these guys. They're going to bounce back, but it's going to take them some time to kind of diagnose what's gone wrong and kind of work out how they can move forward from this. But it's a real shame, because they've been doing amazing stuff. I don't know, Terry, what are your thoughts on this? I found it was really sad.
Well, they have a much better success rate so far than most other, even government-backed agencies. I mean, they've launched 53 satellites so far, which isn't bad going on 12 launches. The other thing is that it's exceptionally good value. Now, admittedly, they can only launch small satellites, but it's roughly $5 million per launch. but they split that between a number of different people launching these small satellites. So if there's 5 of them on a particular launch, that's only $1 million, which is much, much less than the cost of developing the satellites. And they always have insurance to cover the possibility of a failure. Some of them, and maybe most of them, will have backup satellites and experiments ready to go at another occasion. And it's not as if this was something exceptionally major in terms of a flaw in the design of the rocket. If it was just the batteries, that's something that's could even have been a software problem in terms of switching over from the main battery to the backup battery. It's eminently fixable is the way I would look at it, and I would hope that a total success the next time.
Absolutely, and you only have to look at the early days of NASA and the Kaputnik kind of saga, where basically NASA were blowing up like 30–40% of all the launches they were attempting in their early days. So, and SpaceX have blown Pad 39A apart. They've had multiple mishaps in terms of both launch and landing attempts. So it's not a surprise. It was a surprise really from an insurance point of view. I mean, you'd probably be quite happy to go on a Rocket Labs launch because they were having such great success. Obviously, the risk has gone up a little bit now for them in terms of ongoing insurance. And what Terry was saying was really interesting. The cost to launch now is becoming so low that some of these rideshare and small sat, even CubeSat type missions, you can be launching something, a kilo, a 1 kilogram sized CubeSat for $20–30,000, which is well within the range of universities. Even schools are launching satellites into space. It's a very interesting business model, and I think they're one of the only ones in the world currently they're able to almost compete against SpaceX, because SpaceX have completely changed the game when it comes to costs to orbit for launch. Obviously the reusability and the cost reductions that are associated with that. But I really do hope that they bounce back really quickly. As Terry said, it happens to everybody. There's very few organizations. One of the big Ariane 5s when it was first launched blew up on launch. NASA, it's a kind of semi-regular occurrence in the early days, not so much these days, we hope.
Even big company like Boeing.
Oh, well, yeah. Boeing, a prime example of like not so much blowing up, and we'd hate to see what happened with it if SLS goes wrong. But obviously the Starliner projects, they've had to do another test mission because of the issues that they had on the last Starliner test. So massive companies. This doesn't just affect the smaller companies. There's very, very few that escape with this. You look at the Russians with the Soyuz, they've got probably one of the most reliable human spaceflight vehicles ever designed in history. It's almost flawless. But then their Proton rockets and various other things that they've tried to send to Mars, they've lost nearly all of them, either in low Earth orbit or not even getting to orbit. So space is hard. It's the kind of key lesson from this. It's no easy ride. And one day, hopefully, it will be like every other day we'll be seeing a launch, and tourists will be going up all the time. But right now, even 60 years plus on from the first launches with Sputnik, we're still finding it can be quite difficult and quite complex. You're basically building a gigantic bomb and trying to put something on top of it, so it's not easy.
It's interesting that as well as the launch facility in New Zealand, which would be mainly for polar and high inclination orbits, they're developing a facility at the Wallops Air Force Base in Virginia in America. And that would be for satellites in a sort of more equatorial or low inclination orbit. But they're planning to launch their first moon satellite from there in a year's time, as far as I know. That's Rocket Labs,
Well, this is the thing now. There's an awful lot of missions heading towards the moon, relying on very small CubeSat style technologies. There's rovers. There's a kind of one of the British plans is to send almost like a spider-legged mini rover to the moon, which is going to be interesting with the regolith, see how those spider legs cope with that. Launching from an equatorial location is ideal. What is also interesting now, and you look at what's happening with Virgin Orbit and Cosmic Girl, what is the plan for Prestwick as one of the Scottish spaceports? This idea of having these drop launches from aircraft, which obviously then gives you the ability from a single launch site, as it were, to be able to go either to polar sun synchronous or to equatorial orbits, just with the same launch vehicle. So but obviously you're constrained by mass. You can only launch up to a certain mass from these. Having multiple launch sites, definitely a good thing. I think, like I said, Peter Beck and the team at Rocket Labs, what they've done in a very short space of time is got through all the regulatory hoops, they got through all the insurance side, and they're just doing it. And I think that's a really important lesson for the UK in terms of our aspirations for getting into space. We really just need to kind of move ahead and do it. So
yep, absolutely.
And then finally, what not to miss over the coming weeks. So obviously we talked a lot about Comet Neowise, definitely one to see. It's not ideal time of year. The clouds have kind of rolled in over the UK after the 9 weeks of glorious lockdown sunshine that we had, where everyone was out in the observatory if they had one every night. I know I was. But we've got some really nice other things to see, haven't we, Terry, like the opposition and what's happening with Jupiter and Saturn at the moment.
Yep, the two biggest planets in the solar system, very close together in the sky, although very far apart in actual space. Jupiter and Saturn are both coming to opposition this month, and that means that they're exactly opposite to the Sun in the sky, because Earth is closest to them in its orbit. So they appear at their biggest and brightest for this particular year. And Jupiter is almost at opposition at the moment. Apart from Venus, which you can only see low in the morning in the twilight sky, Jupiter is by far the brightest star-like object you will see in the night sky at the moment. Much, much brighter than Saturn, much brighter than any of the stars. And if it's clear tonight, you actually have a chance to see the 4 main Galilean moons of Jupiter, discovered by Galileo himself over 400 years ago. Now, in a telescope, you simply can't miss them. But if you have a good pair of binoculars, tonight is a good chance to look. It needs to be fairly late at night when Jupiter is relatively high up, but you can see the 2 innermost satellites, Io and Europa, just to the right of Jupiter, and further out to the left, the other 2, the outermost pair of Ganymede and Callisto. Now, if you're like me and your hands aren't as steady as they should be, and it's nothing to do with the drink, you need to hold your binoculars very, very steady. If you've got a good big camera tripod, you can mount them on that. If not, rest your elbows when you're holding the binoculars on the top of a fence post or on top of the car roof or something like that. Anything to hold your hands really, really steady. And if you get them in focus and get Jupiter, you should be able to see 4 of Jupiter's moons, which are approximately the same size as our moon, one couple bigger, one smaller. So it's well looking for that, looking out for that. And any time over the next couple of weeks, Jupiter's going to be really brilliant. Saturn also. And then later in the year, there'll be Mars coming along for a very good appearance too. And we'll talk more about that later, I'm sure.
Yeah, Saturn's tilt as well, the ring system is really nice to see. Right now, a few years ago, it was almost edge on, so there wasn't really much to see, but now much better axial tilt. As Terry was saying about the Galilean moons, the other thing that they may just look like tiny little pinpricks, tiny little star points either side of Jupiter. If you watch them over a number of hours, Jupiter's rotation rate, Jupiter rotates every 10 hours. It's incredibly fast given its size rotation rate, but you can see the moons kind of moving around. And if you take images, if you're fortunate enough to have a telescope and you can connect a camera up to it, if you can take images, you can see the moon's changing position. And this was one of the reasons, obviously, we were able to prove that we weren't a kind of Earth-centric solar system back in the days of Galileo when he was being persecuted. But it's also really interesting talking about Io, for example, in Europa. Io is fascinating. If you don't know much about Io as a moon, have a look at it tonight and then go and have a look at it on the internet. It's one of the most volcanically active bodies in the entire solar system. I mean, this thing is just really kicking off with volcanoes all the time, predominantly because of its proximity to Jupiter, and Jupiter's gravity is kind of almost performing an accordion type maneuver on the interior of the moon itself and kind of squeezing it and expanding it and contracting it, and it's causing active lava flows and volcanoes all the time. The whole thing is just covered in sulfur. Again, there was a great BBC kind of drama documentary about visiting these moons that was aired a few years ago. If you get a chance to find that on YouTube or iPlayer, it's really worth seeing. Europa, by contrast, completely different. It's an ice world. And it's the one made most famous by Arthur C. Clarke with 2001 and Attempt No Landings here. But it's one of the moons that potentially is a good shot for life in this solar system. There could be a subsurface ocean on Europa that could harbor life. So well worth a look. And I always try and, when I'm doing these kind of outreach events with cubs or with kids in particular, they'll look at things, and sometimes if you look at an object through a telescope and you've seen it on the Hubble, or you've seen the images on the side of a telescope box, you may be a bit disappointed. You look at the Andromeda galaxy, which is one of the brightest galaxies in the sky, and you see the picture of it, and it looks like this spectacular big galactic structure, and then you look at it through a telescope or a pair of binoculars, it looks like a grey fuzzy blob. It's worthwhile looking up what these things actually do look like, and then imagining what it'd be like to be there. It's one of those great things about astronomy that can really get people hooked.
Jupiter's fascinating because it's always changing. In fact, just before we came on air, found out that some amateur astronomer has discovered a new spot on Jupiter. Didn't get a chance to check it out further because it was literally before we just started this program. But it's worth watching. It was the object that I was most interested in when I first started in amateur astronomy, simply because every night you looked at it, it appeared slightly different. And the satellites, as you say, are always moving. The other thing about Saturn, you can see these fantastic photographs from the spacecraft and from the whole Space Telescope and so on, and even a good amateur telescope is not bad. But to see it yourself, not a photograph, not a video, not a space image, to see it yourself in a black sky in 3 dimensions, I've yet to meet anybody that didn't just say, wow, whenever you see Saturn. It's just incredibly beautiful.
It really is one of those. I remember seeing it about 10, 15 years ago, and it really was. It was one of those, I call it National Geographic nights, where the seeing conditions were great. The only downside at the moment is Jupiter and Saturn are quite low in the sky relatively. Yeah, so you are punching through more of the atmosphere, so it can almost look like you're looking through a swimming pool some nights. Trying to find a good steady night. Obviously, when we've got very limited aircraft at the moment due to COVID, the skies are potentially a bit better. You're not getting as much in terms of aircraft contrails, etc. Possibly atmospheric distortion. You're still going to get the jet stream. You're still going to get the effects that will affect the seeing, but it's worth, if you get a good, clear, steady night, even in the summer, just getting out in the wee hours, as they say where you are, Terry, and having a good look. It's fascinating. Jupiter in particular, as Terry was saying, the great red spot, if you do manage to see that through a modest sized telescope, just imagine that thing alone is a storm system that we've known about for several hundred years, and that could effectively swallow the Earth several times over. And that's just a storm system on Jupiter. Jupiter itself could swallow the Earth 1,000 times over.
That's right.
Quite easily. So it's wonderful to watch, and seeing it rotate, and the differential rotation. It's almost like, if you remember as a kid, an Everton mint, the kind of stripy bands, that's what Jupiter looks like. It looks like a round Everton mint in a small telescope. So well worth a look.
Just one thing that's still worth looking out for, because there was another excellent display of noctilucent clouds a couple of nights ago. We're coming near the end of the season of visibility, but certainly up to the end of July, or the end of the 3rd week in July, you can see them. And there was another very, very good display. It was seen exceptionally well from as far south as Paris. So anytime there's a clear night, round about your local midnight, an hour or two on either side, and that's roughly 1 o'clock in the morning with summertime, when the sky's at its darkest, look low down in the north, or sometimes a bit above the northern horizon, for those ethereal wispy clouds, which are really, really beautiful, and they photograph quite easily with a smartphone now.
Yep, absolutely. I saw some great images from a friend in Colorado the other day. She was out trying to capture pictures of the comet, bizarrely, and then ended up capturing some absolutely stunning images of NLC's noctilucent clouds. So definitely well worth. It's only a few weeks left, as Terry said, in this year's season, but well worth seeing. And especially, as I said, we've got very little aircraft kind of to get in the way, so you're not going to be plagued with contrails, etc. So well worth a look. And on that note, another great couple of weeks in space. I know I've really enjoyed it. Next roundup, as we can see on screen there, a couple of weeks' time. I'd just like to say it's always a joy talking with Terry. I love the guy.
Likewise.
We've been digging up some old pictures.
21st of July is a very significant date.
Why is that?
Okay, bye everybody.
Good night from me, good night from him, and we'll hand you back to Latch just for the final Q&A, if there are any.
There's guys.
Awesome, thank you so much. It's been a pleasure having you. I don't think we have any questions today, but I hope everyone who's tuned in has really enjoyed it. I'll definitely be looking out for Jupiter tonight if I can. Hopefully there's Hopefully it's not cloudy where I live. But thank you so much, Terry. Thank you so much, Nick. I've really enjoyed it. And as Nick said, we'll see you
Okay,
again in
bye.
a couple of weeks'
Bye-bye.
time.
Take it
Bye.
easy.
Brilliant.
Have a great day.
Take
Bye.
it easy, guys. Bye.